All right, so I would agree with the statement based on David said. There was no numbers, it was very subjective, talking about the direction, linearity, strength, and outliers. No maths involved with that. So you're going to feel uncomfortable answering those questions, but how do I know if it's strong? How do I know if it's moderate? How do I know if it's weak? I told you in the previous lesson, we're going to clear that up now. So these currently are just words. They're not yet mathematical representation of a correlation. So the first indicator of a correlation that we deal with is known as Pearson's correlation coefficient. It's represented by a lowercase r. So what is Pearson's correlation coefficient? It's a number that goes between -1 to +1. The sign of r indicates the direction of the correlation. So if the sign of Pearson's correlation is negative, we're talking about a negative correlation. So I think on your sheets, I've got a place to add that there. So R, Pearson's correlation coefficient, is going to tell you the direction of the correlation, where the dots are going to go. If it's negative, you're going to have a negative correlation. If it's positive, it's a positive correlation. So add those words to your sheet, please. And then the size of R, the size of Pearson's correlation coefficient, so how close it is to 1, indicates the strength of the correlation. So here, like we mentioned, I'm clarifying that now it's not going to be up in the air. The best way to summarize how to describe Pearson's is there's a table in your textbook, but I've pasted it here. And it's pasted now in your books because you can paste that in. For your note sheet at the end of the year, can you guys have a look at that table? Can you explain to me why you'd only need to draw half of this table to cover all of Pearson's? I don't think you should waste time drawing that whole thing. Why would it be okay to do half of it only? Yeah?
Because if it's negative, then you just switch it.
Yes. Only draw half of it. Because as you can see, if R is +1, it's a perfect but positive correlation. So it goes up to the right. The only difference when it's -1 is it's a negative correlation, so it's going down to the right. What you need this table for is to decide, if I've used my calculator to find what R is, I need to know what words to use to describe that correlation. So if you get 1, you're going to say it's perfect. If you get a number between 0.95 and 1, you're going to say very strong. If you get a number between 0.87 and 0.95, you're just going to say strong. See how before it was a bit up in the air? Now it's not up in the air, but you're probably questioning to me, how do I get this R? That's what we're going to do now. So can you get your graphics calculator out, please? Or grab one from the front if you don't have one. Clearly using R to indicate correlation is more mathematical than what we did before, which is just words. However, you need to know how to find it. R is one of the many stats you can find on your graphics calculator after you've entered data. So, these two things, do you agree that after I taught you TVM solver, you hammered TVM solver over and over again? For statistics, you're going to hammer this. You need to know how to enter data. That's the first thing, which I'm going to demonstrate. And the other thing is these steps will be repeated later, but this is how you're going to find statistics about your data. So let's pretend that we're entering data. In this topic, you're going to be asked to find stats about data sets. You're going to use your graphics calculator to find those stats, but you can only find stats if you've got data in the calculator. Right now, your calculator has no idea. So how do I enter data? On your calculator, press second, the blue button, and go down to, can you see above 0, it says catalog in blue? All right. You're supposed to find the diagnostics menu. So normally you could scroll down by pressing the buttons here, but that's going to take forever because you're starting at A. So if you want to skip down quickly, can you see a button that says D on your calculator anywhere? In green? If you just press X to the -1, see how it's got D in green? It skips straight down to the D's instead. So it's a shortcut. Now scroll down from the D's and find diagnostic on. Have that highlighted, press enter. You haven't actually turned them on yet, press enter again, you've turned diagnostics on. Okay? That needs to be done. Once you've gotten the hang of this, if you know that you've already turned diagnostics on, you don't have to do that again. But to cover my ass, basically, I'm going to make that first step all the time. In case, like in the exam, you have to use a school calculator. You don't know that diagnostics is on, so always just turn it on. All right? The only time it would ever turn off is if you had to reset your calculator. So that's why I've added this red one here. If you've already turned diagnostics on, it's going to be on already. How do I enter data? Can you see a button that says stat anywhere? Whereabouts is that button that says stat? Yes?
It's right below delete. So
Delete next to the arrow, so press stat. Edit, so select one edit, and you can see tables. Just like in science, when I want to collect data, I put it in tables. You'll see a table with columns L1, L2. So you enter your data into the lists. Please, can you get into the habit of putting your X data, the independent variable, into L1, list 1, and the Y data, the dependent variable, into L2. It's not going to be right or wrong if you don't do that, but it's just going to be quicker for you if you always put the independent one in L1 and the dependent one in L2. It's just a good habit to form, right? So I'm just going to make up some data. I'm going to go, my X data was 1, 2, 3, 4, 5. And I'm going to put my Y data 1, 2, 3, 4, 5. What would, if I graphed that, what would it look like? Well, say it loud. Straight line, and the dots, would they be perfectly on that line?
Yeah.
Yes. It would look like that. So according to what we've talked about, what should Pearson's correlation coefficient be for that data? Positive what? It's perfect.
1.
Positive 1. So I've entered the data. I've shown you how to enter the data. I'll show you again. I'm going to quit out of this. How do I enter data? Stat. 1 edit. Put my tables in. X data in the left, list 1. Y data in list 2. Enter your data into the lists. Also, just if you accidentally make a mistake entering data, please don't go to L2 and press delete. It deletes the whole column. Okay? If you want to clear it because you made a mistake, you'll go, what was it? Press clear and press enter. It's going, what do you want in that column? I want nothing. And you press enter and it clears it, right? Because I'm going to go to L3. If I press delete on L3, it's deleted L3 completely, okay? Just in case you want to know, I'll show you how to put it back. I'll go second insert, and it goes, oh, what do you want the name to be? And can you see in these buttons here, you've got L3 in blue. Second L3 on 3, you put it back. I don't want you to freak out like that, okay? If you've accidentally put numbers in incorrectly, 1, 2, 3, 6, 9, 10. Oh, it's going to take me forever to go and clear each of these individually. I want to start fresh. You go up to list 2 and you press clear, and then you press enter and it clears it instead of deleting the whole column. I'll put those back. So we have a perfect positive linear relationship here. How do I find that data? How do I find Pearson's correlation coefficient? Ensure you've entered your X and Y data. Have we on the screen? The X and Y data is entered. Press stat again. Use the arrows to select the calc menu. So can you see calc is on the right? So you move to the right once. And then you scroll down and select 4, which is Lin Reg. And you press enter. And the calculator here is double checking. Did you put the X data in list 1? See why I'm saying that you form that habit? Always put your X data in list 1 because it asks for it. If you do it, then you won't have to stuff around. If you always put in X in list 1, you don't have to stuff around. It's automatically done there. Y data is list 2. Ignore frequency list. Ignore that. You just go to calculate. And can you see there? What does it say R is? 1. Because the dots are perfectly on the line. Go back. Go start. Let's edit the data slightly. Make 5 6 instead. Is that going to be a perfect correlation anymore? No, this last dot is going to be a little too high. But is it going to completely change R? Is R going to be something ridiculously different? It's just going to be slightly less. So try it. How do I find the statistic? You press stat, you press calc, you go lin reg, you run the lin reg again. See how it's not? It's still close to 1, but it's slightly less. Why? Because it's not perfect anymore. Okay? And so you see on this screen, it tells you the equation of the line, it tells you the slope. We're going to do stuff with that later, just not in today's lesson. So can we do an example and you tell me? I have data here. I'm going to pretend that the calculator is fresh. The Botanic Gardens have been trying a new chemical to control the number of beetles infesting their plants. The results of their tests are shown. Draw a scatter plot for the data. I've drawn that for you. Hopefully you can put dots in a graph. Whether you like it or not my concern. It's for your exam, okay? Let's determine Pearson's correlation coefficient. So you have a bunch of data. Please double check. In this scenario, which variable is causing the other variable to change? The chemical is going to kill the beetles. So the amount of chemical is the one that explains the change in the other. So L1, I go stat, edit. I've got statistics from a previous question. Can you remind me how to delete this without deleting the whole column? Yes?
Select L1.
And clear, enter, clear, enter. Okay, let's enter this data. So the independent variable is 2 grams of chemical, 5, 6, 3, 9. And the independent variable was 11 beetles, 6, 4, 6, 3. You can already see, just looking at the data, the more chemical, are there less beetles that are living? But is it going to be perfect? These numbers mix around. It's not going to be a perfect scenario. So can you remind me? I've put the data in now. How do I find statistics on that data? What do I press? Stat. Calc. Lin reg. We formed that habit, right? Scroll down to calculate. So that's telling you what direction is the correlation? It's negative. Is that what we've got in the scatter plot? It's going down. Is it telling you it's a very strong correlation? Nope. You should just saw my desktop. So R equals negative 0.8589. I've done that to 4dp. And C, it says describe the correlation between the quantity of chemicals and the number of surviving lawn beetles. It looks like it's forming a straight line, but now I go to my table here. Where would it sit? Which one of these?
Well, it depends if you round it.
It still wouldn't depend, because if you rounded that to 0.86, it would still be where you said. Moderate. It's between 0.7 and 0.87, but it's negative. So you just use the table. There's no weird interpretation. I'm a bit scared. You look at the number now, and you say it's a moderate, negative, linear correlation. Moderate, negative, not negative, negative, linear correlation. So just like I said, try to get fast with TVM Solver. The first half of this topic, you see a table of data, you can pretty much bet you're going to enter it into stat edit and you're going to run stats on it. Okay? I'll stop there.